Ron Bodkin, who is here today from Think Big Analytics. He is founder and CEO, and this is designed to be a Q&A, so there'll be some questions coming up on the screens on the side, and we'll be trying to hit on those questions. After some initial response from Ron, then microphones will be coming along, and if you'd like to ask a follow-up question, we'll do that throughout the session as opposed to waiting till the end. And so with that as our introduction, we're going to start by turning the floor over to Ron for a brief description of what he does and his firm, and then we'll get into the questions. Welcome, Ron.
Well, thank you. So I'm Ron Bodkin, founder and CEO of Think Big Analytics. And Think Big is a specialized consultancy. We help companies implement big data applications. We do both data science and big data engineering work on top of these emerging big data platforms. We started the company about 3 years ago with that as our exclusive focus. So we work with technologies like Hadoop and NoSQL and predictive analytics, distributed machine learning. We started the business because we felt there was a huge shift happening and a huge opportunity in the market. Prior to being a founder at Think Big, I was the VP of engineering at a pioneer in the space called QuantCast, where we put Hadoop into production back in 2006 and processed petabytes of data, first to disrupt the audience measurement market, to understand what kind of people were looking at websites and responding to ad campaigns online, and then subsequently to do real-time analytics to decide on what ads to show people at what time for what value. In that experience at QuantCast, I had a chance to lead the engineering and science teams that really followed many of the same patterns that are now more broadly used in other industries, of being able to work with data in a raw form at massive scale, to be able to produce models that then are executed and acted on in near real time, and the insights flowed back for continuous improvement. So since we started Think Big, we've been engaging with customers across many industries. We're doing a lot of work here in the Bay Area with leading technology companies, large hardware manufacturers, software manufacturers, providers, working with device data, network data, as well as large financial services firms. We at Think Big are big believers that there's a whole class of techniques around big data that are unlocking measurable value for businesses, that there's a real opportunity to take, whether it be data from devices that are phoning home, from sensors, from software logs that are being captured on devices around the world, or whether it be consumer data, blending the classic notion of information about a consumer with their web interactions, their mobile interactions, with location information, with rich CRM and call center information. So we think that there's such a range of applications, but the common patterns are really around an agile approach, aligning the business and the technology execution, moving quickly, testing and learning to get to value. Today I'm certainly excited to share a little bit about what we've learned in the 50 plus projects we've done since we started the business, and talk a little bit about some of the trends and what we see going on around how big data is impacting the business world.
Okay, great. With that introduction, we have our first question coming up on the screen.
Drum roll. I hope that's not a question.
No question there. So to what extent do you believe big data is changing the dynamics of business in various industries?
So definitely, we think that big data is really a seismic shift, that we're breaking free from a lot of the data processing and storage approaches of the past were rooted in the kinds of capabilities computers had back in the 1980s, where you had it's hard to imagine how impoverished computers were back then, how a few megabytes of storage were scarce, how processors were so much less capable than what they are today, how slow networks were. And as we say, look, we now have these amazingly capable computers that we can put together in clusters and store massive amounts of data and do massive amounts of calculation. It's changing the game. And what's changing is it's now possible and really incumbent to store a lot more data. Don't just store a summarized transaction of I bought something. Store information about what was going on, where people are going, how they're interacting. Take data from all these devices, cell phones, smart automobiles. We see more and more companies that are manufacturing devices and equipment have instrumented them with sensors and have software on board that can crash and fail, that needs to be tracked and integrated and used to get more intelligent. So we see this basic approach that data and information is being integrated into the supply chain across industries, that you're seeing a need to have a capability to have companies compete on the basis of their ability to be intimate with customers, to use information to understand their customers, to respond, to intervene before they lose customers, and for companies to take all the insight they're getting from intelligent products, from interactions with software, to start to climb the bar. Don't just sell a basic service, but start to sell analytics, start to provide insights and comparative capabilities. So we're seeing the axis of competition shifting to data and analytics are becoming core to many industries and the kind of products that they're offering to customers and how they differentiate to create value.
And so as follow-up, in the question it says across various industries, and so your answer basically laid out that there's a lot more data being created because of devices and other reasons, and the storage cost has come down as sort of the second leg of the triangle, and then the third leg is, so now what are we going to do with it, and that's the analytics piece.
Right, so there's definitely the opportunity to do analytics, to start to drive to more insight based on rich data sets to make smart decisions, and ultimately to do more automation, to start to have systems that have intelligent algorithms that predict what's going to happen and automate responses. So you have smart people looking and saying, how do we get to smarter offers for our customers, or mitigate churn, or diagnose problems based on exceptions, and continue to have systems that are automatically getting smarter instead of an older paradigm of human curated rules that are being manually edited and maintained with little accountability for how well they're working.
Okay. We can open the floor to a follow-up question to this broad introduction about various industries. There's a microphone coming around if you put your hand up. Couple hands. Is one of my mic runners out there with the mic? Saw one right in front of you. Put your hand up again, please. Thank you.
Hey, Ron. My question was more around, if I kind of give you a use case where we collect, let's say, some information about behavior, customer behavior, and we want to use it in a real-time manner, let's say at the point of shopping where we give a differentiated offering or something like that, can you talk about the various set of tools that we will need to accomplish this, where we respond in a more real-time manner, not necessarily in a reactive manner?
Sure, that's a great question. You know, the way we see it is there's usually a set of technologies that are important for a real-time response, as well as a supporting infrastructure for storing history and allowing for batch analysis and testing and simulation, and they work hand in hand, right? So the real-time infrastructure will typically start with some kind of scalable storage mechanism, a NoSQL database, so that if you've got millions of consumers, for example, or millions of devices, you can get information around, what do I know about this individual based on their history? I've summarized a bunch of information from a model, I have an idea about what their interests are, and I'll complement that with low latency signals, near real-time information, like they just looked at this item. That means they're probably interested in this thing, and I need to update my model of what their interests are based on what they've just been doing, right? So it's a read-write database where I have a long-term propensity interests of the person that I've computed from a model that's going over a massive store of diverse data sets, and it's being pushed out into a execution environment where I have quick access to know about them and complement it with information about what just happened that's in that same model. That then is used to derive a predictive score to say things like what's the most likely things they're interested in, or what's their attitude, or what kind of problem might they be running into, to allow for a response, whatever the channel. It might be tailoring a web page based on this individual and what they're doing and interested in. It might be informing a customer service representative who's talking to the person to say, this is our model of what this person's interests and concerns are. So the real-time response is being powered at minimum by technology that allows you to have low latency access to data. What we tend to see is the first implementations of that will use basic technology like web servers, application servers, but over time, as you get more complex and sophisticated execution, There can be a lot of value in streaming big data systems where you can have more ability to distribute real-time processing across nodes. As well as the other thing that often comes up is some kind of a distributed search technology becomes important, that there's a range of real-time use cases where you want to be able to quickly look up an item. For example, what is this issue coming in about, or what product do I want to find here? So complementing models around individuals where you predict their interests with the ability to quickly look up information in real time and present relevant information.
Great.
Yep, sorry, go ahead.
I saw a second question over on this side.
Hello, my name is John Souls, TechSoup Global here in San Francisco. I was wondering if you've done any research or focus on nonprofit data, NGO, CSO data worldwide, and how to better maximize visibility and transparency of that data?
So it's a good question. I would say at Think Big, our focus has been more working with commercial organizations, private for-profit businesses. I think there's a lot of value around some of the NGO data. And there's both opportunities to create a lot of social good, as well as interesting opportunities for collaboration between nonprofit, government, and private sector organizations. There have been some notable examples of private corporations that have made data available for things like predicting outbreaks of disease, making data sets available for data mining to serve public policy goods. I think that there's a lot of opportunity also where governments are increasingly embracing open data and making data sets available that can totally be a resource for nonprofit purposes as well.
One more question, and then we'll move on up toward the front here.
Hi, my name is Adil. I work for a strategy consulting firm called Strategic Decisions Group. My question was around the relevance of big data for B2B companies, because for B2C it makes sense because there's lots of data to be had. But are there use cases for B2B companies using big data?
So it's a great question. And really, we believe that the biggest data set of all, that's the most important for big data, is machine-generated data. So, for example, we've done a lot of work with large storage companies that have information from devices that are installed in thousands of clients' IT data centers that phone home information for support. That's a good example where that's a B2B use case. There's an IT provider working with their customer that is an IT department, another business. But there's literally a petabyte of data that's collected over the history of these devices. Their alerts, issues they're running into, their configuration, their updates, interactions among those components, in some cases their environments, right? So those kinds of machine data, device data use cases we see as very relevant for businesses, where B2B providers, where the kinds of things that are important there are being able to drive better service around those devices, being able to drive sales through better understanding usage patterns by customers, be able to position new offers, to allow data-enabled product management, understand what things are really happening installed in the field in these B2B devices, as well as, in many cases, we see B2B providers looking to provide more business value, to collect data from their business customers around device interactions, around items that are out in the field, and be able to provide benchmarks or analytics, best practices on top of those data sets. And that's just one example. We see the same thing for companies that are manufacturing industrial equipment or in the energy sector, among other cases where we have customers that are applying big data to machine data in a B2B scenario.
Well, great job by our contributors in the audience. The follow-up to various industries was threefold. We had real time, and we had NGO, nonprofit, as well as B2B, so that was great discussion driven. And as we move on to our second item, can you give some examples of habits of successful big data implementations?
Sure. Well, I really think that the key to a successful big data implementation starts with how you set things up, having the right goals, having a business objective of what you want to achieve, and being very clear around a path to get to a success and then build on that success. So in Think Big, we often start working with customers with what we call a roadmap process to understand the business cases and prioritize, where the goal is to find some low-hanging fruit. What are areas where there's low risk and high value to the business? That could mean driving new revenue. That could mean reducing cost in an operational area. That could mean starting to test a new offering or capability to a customer. But aligning that with a business objective and being able to do a quick pilot, how quickly can you get something out, and starting the virtuous cycle of testing and learning. The book of how to use big data in each industry is still new. People are writing it every day. There's lots of innovation. So there's just no substitute for an agile process of getting something implemented, learning from feedback, adjusting, course correcting, and getting to a result. Right? So we're big believers that you need to have a process where you get things out live quickly, you have lots of feedback, things you measure to understand what's working and not, and course correct. That includes an integration of engineering and science capabilities, so both the ability to integrate new data processing techniques in with new applications, leverage your existing infrastructure. Big data isn't coming in as a rip and replace for established systems that are working and established data stores, but it's complementing them with new capabilities that were never before possible. So we see that as critical, having a process of testing and learning, doing rapid releases, and we're big believers in having a team that works together with the business on site together, not a remote team that's working in a different country or a different locale, really coming together to drive value through rapid cycles of agile process.
And so you used the term low-hanging fruit. Last month I was at MIT at the Sloan Sports Analytics Conference, and one of the talks was about how to get coaches and players to buy into analytics in sports. And sort of the same theme, not using the term low-hanging fruit, they said, can you get a win early? Can you demonstrate the value, and then you can get a more successful implementation? And that sounds like that echoes the same idea that you're putting forth.
Yeah, for sure. I mean, I think it's human nature that when you do adoption, you want an incremental approach. You want to start small, get to results, and then scale up from that success. So it's finding that right champion, finding the business case that produces the demonstrable result with a reasonable amount of investment. You know, many businesses do have an established investment in analytics, but often in a very specific context. People have been told for so many years, you could only work with 60 days of detailed data. We only have summary information for that. It's not possible to calculate that. A lot of times we have to work with customers to say, let's forget all that for a minute and think about what you'd really like to do if you could, and brainstorm based on that around what have you always wanted to do, but you always thought we could never really do that.
Right. And so that could be that early big win,
Right.
and a buy-in from the client in this case, or internally if you're within a company, to get others to buy into that worldview.
Yeah.
Great. Well, with that opening discussion, did we have some follow-up on the habits of big data implementations or steps toward a successful big data implementation? We have a question over on the side here. If you can keep your hand up, he's on his way with the microphone.
So far, we have been only hearing good news and success stories. Could you explain failed projects in big data and what caused them to fail, and what steps need to be taken to avoid those things?
So the question is, what are the kinds of things that cause failure in big data projects?
And also a few examples of failed projects, if there are any.
Examples of failed projects.
Yeah.
Okay, so I would say that what we've seen is one of the more common modes of failure for big data projects is actually limited success, where an organization will get some level of capability deployed. Maybe they figured out how they can load data into Hadoop and reduce some cost by doing some of the transformations in that environment instead of a data warehouse. And then they kind of hit a plateau where they don't have the sponsorship or the ideas of how to move beyond that initial success to create more value in the business. How do you connect this with creating new revenue, driving new products? So there's often a failure of imagination around how do you take the capability and extend it to that next level to create more value. Right? It's a lot of that is driven by organizational challenges. How do you break down barriers? People may feel threatened by new technology and approach. And honestly, to drive to higher value use cases takes both the patterns and experience of what's going to work as well as a focused effort to drive them, right? So it takes some sponsorship and guidance to create that value. Now, we also have seen cases where organizations have failed because they have followed an approach where, lacking that governance, they often have gone after big data as more of a business as usual approach of, we'll try to use maybe an organization, a supplier of ours that doesn't have a lot of these skills, but just started offering support, consulting around this technology as an adjunct to their established data warehousing business intelligence practice. Maybe we'll try to do it ourselves with a little bit of training. And what we see a lot of times is organizations don't recognize that there is a mindset shift. There's some new patterns on how to work with this data. It's these systems that they're powerful, but they're not as mature. They're not packaged products, and that there's a lot more experimentation and innovation required, right? So failing to put the right structure where you're being agile, where you're learning, where you're engaging specialist experts, we've seen generate failures in projects. Now, any project, fundamentally, I think the biggest thing that causes any project to fail is not being set up with the right expectations and the right resources to achieve those expectations. And so those factors of saying, well, let's go with a very incremental approach, assuming this is very much like what we were doing with our previous data warehouse technology, is a big mistake. And we've seen a lot of organizations have to hit the reset button and realize that the kind of resources they're able to bring in under that paradigm and the kind of ways they've set things up aren't working, and they need to take a fresh look in order to recover from some challenges like that.
As a follow-up on the failure question, wouldn't we expect that there would be some failures? I mean, so much of this is trial and error that, is it an organizational cultural mindset that they're just unwilling to fail, or at the first sign of initial failure, they're like, maybe we don't want to do this anymore? And so do you run into some of that as well?
That's a great question, because I think there's two kinds of failures. There's sort of healthy failures and unhealthy failures, right? Where in a test and learn model where you're testing business ideas and you're trying things out, you can expect a lot of the experiments you run to fail. But you have to look at those kinds of experiments not as failures from a project standpoint, but as learning, and say that, look, you're going to have a range of things you try out, and the things that succeed will more than pay the cost of all the things you tried, right? So that's actually really healthy and inevitable. That's what we see in any company that's leveraging big data and creating value, is you've got a lot of things being tried and not all of them work out. So that I would put more on the healthy side. I was addressing the opposite kind of failure of projects that simply didn't deliver on a fundamental thing you're trying to do, where maybe it was less about verifying that a given set of data isn't useful for something, or a given approach isn't going to produce an improved result, but more not being able to execute effectively, not being able to even give it a fair shake.
Any other follow-ups on the implementation, successful? And two over here, one here and then one in the front row.
Big data, the output of that is really the decision making, right? That's what you're driving, really. Now, when we think about decision making, it has a time bound. Any decision, at a time, you make a decision and then you move on. So given that context, let's say we are solving a big data problem for a CFO. That problem could be totally different from a VP sales of the same company. So given that, how do you see a CIO of that, that company who's serving to CFO and as well as the VP sales, putting some kind of common structure and a business case for a, long-lasting time?
So if I heard that right, there were both the question of statement that big data is primarily infrastructure that drives visualization, and that there can be very different domains, that you might have different constituencies of the CIO, and how can you serve those different constituencies with a common infrastructure? Is that the question? in a timely manner. So let me tackle those two parts in order. The first is I'd say that certainly we see big data being rolled out in 3 stages of adoption in most organizations. The first tends to be scalability and cost containment, being able to have an infrastructure that can scale to hold more diverse and larger data sets with faster analytic times, and cost containment in terms of being able to do it more cost effectively. The second, where visualization definitely comes to the fore in a meaningful way, is around agile insights, being able to have better understanding and spending a lot more time living in the data, understanding what's going on, drawing insight from it, and less time wrangling data, less time programming, transforming, organizing, having projects to move data around. And then the third stage, business optimization, tends to be very much more focused around automating decisions, which instead of driving visual analytics is driving predictive models that are integrated into automatic flows. So when somebody's on a website, they get to see a certain offer, for example, or you make a real-time decision around credit risk. So those kinds of, or indeed a device phones home and you say this device is about to fail, so let's proactively service it. So there are cases where people don't just visualize, but actually are automating decisions based on big data systems. So that's the first comment. The second comment is it's definitely generally usable infrastructure. So you're right that many different business units can take advantage of big data and be served by them. And there will often be some common data sets that are necessary to serve different purposes, right? The VP of sales and the VP of marketing and the VP of products in a company might each have reason to look at customer transactions, CRM relational data, web interactions, but they might do very different things with them. So I'd say that there's often leverage in having common environments that can scale to support a range of analyses, but at the same time, you certainly do need to have an approach for how you work with those different groups, each of them needing to have a clear business objective of what they're trying to achieve. And you'll find that there's different data sets and different focuses for different groups. So, we do see most organizations starting with a common shared big data environment, especially for batch analytics in Hadoop. Often you'll see different systems of engagement that have separate real-time environments that you'll tend to have for different channels, different systems that are engaged, that it needs to integrate in with your existing systems. It's not a rip and replace.
And we had one more question before we move on, right here in the front row. Oh, he's bringing the microphone so everyone can hear.
The data life cycle of big data. I keep hearing about you can add and scale and grow and grow and grow, but I get concerned about when that bucket gets filled up. I've seen and read very little about that. Could you comment on that?
Sure. Well, it's definitely true that the economics of data change a lot with big data technologies, that you've got typically our customers are seeing nearly a 2 order of magnitude reduction in price for a given cost of storage or processing of data. And so that definitely changes the balance of what amount of information you retain. We often see that leads to patterns of keeping raw data and then computing derived downstream views on that data, derived summary, derived organization of that information while keeping the raw upstream data. But that doesn't mean that storing information is free. It's less expensive. Processing is less expensive, but of course it's not free. So what we do see is many organizations say that there's a large set of data that they will retain for years in a raw form, if not forever. There's other organizations that we work with that say, look, we just can't afford to keep all this raw data even still. We're still going to have to make some selective choices around what data we keep and maybe have a strategy for retention policies on some of the raw data. Maybe we keep some sampled data for older data sets that we can't afford. In general, we view that keeping raw data is a great investment in the future, that we see a lot of value being created. So in most cases, organizations that have even hundreds of terabytes or petabytes of data are finding it worth their while to keep data in a raw form. But we have seen companies that are pushing hundreds of terabytes, exabytes of data, thinking harder about the cost of that retention and the business case for that data. So it certainly is a case-by-case question for the largest data sets.
Okay, and we'll move on to our next broad question, which is how does Think Big support business outcomes? So we've covered some of that, but do you have additional?
Sure. So, as we talked about before, we see that it starts with what we call our Imagine process, a roadmap to help think through the business opportunities and charter a program for what's your roadmap, how do you roll out capabilities to get to success, so how do you incrementally deliver value along the way so that you get more and more out of big data over time. So we work with customers on that Imagine approach for setting the strategy and roadmap and implementation to quickly roll out new capabilities, test and learn, and get to value in deployed systems.
Great. So what are the greatest threats or pitfalls to big data projects?
So certainly that's related to the question earlier around what causes projects to fail. I think that fundamentally, in order to, the biggest pitfall is that we see is probably lack of sponsorship, not setting up projects correctly. Sometimes we also see organizations that, because there's so much excitement around big data, you also see cases where organizations get very excited and believe that this approach will solve world peace, that they're going to solve some incredibly hard problem that they face as a business, and it's not like big data suddenly made making organizational changes easier, and it doesn't mean that you relieved some of the challenges of governance and how do you get people to work together to achieve results in the business, right? So we definitely see also organizations that maybe overreach a little bit, that it's easy to say with big data, hey, we want to transform our position in our supply chain, our position in our industry, and we want to become kind of the dominant information hub of our industry. Now, needless to say, it's hard to become the dominant information hub of an industry, and it's usually not your low-hanging fruit first step of what you ought to do as a strategy, right? It's like you need to move incrementally to achievable results that get value and invest quickly. I mean, we've definitely seen organizations that have set, boil the ocean goals and have got funding to take a couple steps, but they didn't succeed in boiling the ocean, and then they leveled off and weren't able to get additional funding to continue their journey. Right? So we think that one of the biggest threats is having the wrong sponsorship or not having a clear strategy around how to get to measurable results quickly and then build on that success.
Which comes back to in your earlier comments, you said that you can look back and see that they had the wrong plan. You didn't say look back, you said the organization has the wrong plan for how they want to use big data or what they're trying to accomplish. Is that easy to see post hoc? Sure, but are you seeing it as it's going on, or from your role working with the company, are you trying to guide them in the direction, or hey, I think you're headed down the wrong path? How easy is that to do, and what's the buy-in when they're trying to overreach?
Yeah, so definitely, our goal as a consultant is to help guide customers based on, we see a lot more of different companies and their strategies in different segments, different industries, what's happening. So we try to guide customers to what are first steps that'll succeed, what are follow-on steps that will build on value based on analogy from within your industry or other industries, what's working and not. So it's very much based on, let's take what's been tried and learn from what already is known and apply that. There's certain, as I said earlier, there's certain kinds of failures where you're trying something that's never been tried before, that's plausible, that could produce some real results. It's worth doing a lot of those kinds of experiments. But you want to do it in a context where if you're doing something experimental, you have enough at bats, in the sports analogy, that you have a chance to get some base hits and prove some value. You don't want to have just enough budget to do one thing and then hope that it works.
And in that scenario, if there's limited budget, it's about tempering the expectations. What kind of project are we doing, and what do we expect the outcome to be? The outcome might be that we're not going to learn anything new or anything substantial, and so it is about that expectation setting at the front end, I would imagine.
Yeah, you definitely want to have the right expectations. And again, going back to low-hanging fruit, what are ways that you can get to some measurable business value that sustains your ability to use big data in the organization and build on that for success?
Great. We're coming down to about 10 minutes left, and so I thought we would just open up to questions generally. And I know hands went up right away. There's one right in the front here, if somebody has the microphone. And then there's one way in the back, of course, as life goes.
I'm curious, who within a business typically contracts with you? Is it from IT? Is it a CIO? Is it the business? Is it a business intelligence group? Excuse me. And then secondly, are part of the services you provide also around process? So a lot of the innovations that would come through some of the solutions you derive clearly have some process change involved. So if you could comment on that as well.
Certainly. So, the first thing is we see in big data projects inevitably have to have business sponsorship as well as IT sponsorship. So we have seen both scenarios where we've had innovative business leaders, whether it be a chief marketing officer, whether it be a VP of service, whether it be a VP of a product, that are driving to use big data to create value in their business, a GM of a line of business, maybe an information product. We've seen all of those as sponsors that we've worked with, as well as innovative IT executives, CIOs, SVPs that are working with a business partner to create value, right? So we tend to see that combination of business and IT in alignment to create value, and we'll often work with a business executive, but sometimes also an IT executive to drive the project. Now, in terms of use of process or guidance on process, we definitely see that coming to the fore when you start getting into data science, as you start seeing what are the practices for working with data and these new capabilities. How do you align it with the business value? How do you drive to the insights? So some of that comes about from data engineering, simply building systems and enabling analysis, but it really becomes a bigger emphasis when you start saying, how do you change the organization to take advantage of big data? We have training, we have our Illuminate services where we'll often work with statisticians, analysts, business innovators to teach them some of the new tools and techniques for working with big data to get to results. So we often see a need to help customers use the data and guide them on best practices and work with them to drive to analytic results.
And there was one in the back. If you could put your hand up again. Great.
Hi there. I'm just curious about how you were able to get ThinkBig Analytics off the ground. What sort of factors were in place when you started this enterprise, right? Resources, context, team, that kind of thing. How did you sort of get the firm going?
Sure. Well, we started ThinkBig just about 3 years ago, and it was back then. People would more often say, "What are you talking about? Big data? What is this thing? Hadoop?" So definitely in that time, there was a lot more educating organizations of how this technology that had been done out on the West Coast by internet companies was relevant to the broader economy and industry. We had conversations with Fortune 500 companies back then where they literally would say, well, we think this technology is just for the kids working at internet startups and it's not relevant to us, right? So back then, that was a lot of the challenge. The way we built the business is I and the other founders of the company had previously built a similar kind of consulting business around internet called Seabridge, and we were able to recruit a lot of people that had that experience from our past team of working with companies to help drive results out of an emerging technology, connecting it with the business. We combined that with my background from having been at Quantcast and having a lot of contacts from being in leading teams that did big data engineering and science projects in the early days. We were able to bring together a team of excellent architects and data scientists from our network, people that we knew from our past work in industry, and then be able to build on those early successes with referrals from other customers. So we've been able to continue to grow the business based on those early successes.
Okay, and that puts us right up against our time. A nice round of applause for Ron Bodkin from ThinkBig Analytics.